So, hello everyone, what's up? So, today we'll be covering the topic of red black tree. So, what is red black tree? Any guesses? Red black tree is basically a self-balancing binary tree. And by binary tree, we mean that suppose this is a root node, so we'll have one left child and one right child. Two either left child or right child. So, it has some specific properties that we'll be covering in our next slide, but for now, we'll understand how this works. So basically, we'll have one red nodes and black nodes. How will we be representing them is we'll be drawing our nodes. For now, we'll be drawing our nodes. Whenever you'll present your work, you'll be drawing the nodes all with the same pen, but whichever will be black, you'll signify it by capital B or capital R, where B represents black and R represents red. So now let's see the properties of red-black trees. So now let's start with properties. Properties. So first property is that your node should be either red or black. This is obvious as we can see from the name of the topic, but still. So basically what I mean to say that either it will be a red or it will be a black. And your root node will always be black. Root node will always be black, irrespective of recoloring. Irrespective of recoloring. Your second property is that red node property. The second property is called as the red node property. The red node property states that there can't be two adjacent red nodes. We'll be doing some examples of insertion by which will make this concept crystal clear. So next is your black depth property. Black depth property. It says that the number of black on left is equal to number of black on right. Okay, so last property is that all leaf nodes are black. All leaf nodes are black. Basically, what I mean to say is it will be a nil node. Suppose let's assume this is a red black tree. So when we are making this will be black, red, red. We'll understand how we are doing this in a later classes. So nil, nil. That means that your end leaf node will be black. This will be black. So now that we have covered the properties, now let's start with an example. So first, we'll take an easier example, that is insert 10, 18, 7, 15, 16, 30, 25, 40. So now, first of all, what we'll do is we'll insert 10. And we have to remember that whenever we insert any node, it will be taken as red if it's a leaf node. Now we have neither do we have a left child nor a right child. But as we can see, it's the root node. So we can't have it as red. So we'll convert it to black. Now next, now we'll basically do like we do in a binary tree, how we insert it. So 10, 18 is greater than 10, so it comes on the right side. Now if this is black, it's our leaf node, so red. Then we have 7. 7 is less than 10, red. Now, 15. 15 is greater than 10, less than 18, red. Now, as we can see, we have two nodes which are red in color and they're adjacent. Therefore, what to do? Let's see. A short trick. Short trick. Short trick is if uncle is red, recolor and go. If uncle is black, then you rotate and recolor. Now, for those who don't know how, which is your uncle, so this will be your grandfather, this will be your uncle, this will be your parent, and this will be your child. It depends on how we are, which example we are taking, but basically this is what we do. So next slide, let's see. So we saw that we had a collision of 10, we had 7, then we had 18, and then we had 15. Red, red. So now, as we have a red-red collision, what does it say? If uncle is red, you recolor. Uncle is red. So here we can see child, child's parent, parent's uncle. So this was just for our explanation, nothing as such. So now 10. You can't change the color of the root, but you can change color of the uncle and the parent. So black, 18 will be black, and then 15 will be red. You will not change the color because we want to prevent this red agency. We don't want them to be adjacent. Red. We don't want that. So this is what we do. We recolor and then now next step. Now we have to insert 16. So 16 red. Again red. But as we can see, now you may be seeing the example that I had taken. Grandfather, this was your uncle, parent, child. Now you will say here, I'm not able to identify which is my grandfather and which is my parent. So just assume this is the child, this is the parent, and this is the grandparent. Assume this to be your uncle, not your grandparent. So now when you do that, what you'll do is when it's black, you rotate. Rotate. Now for rotation, this is your left and right rotation. Left and right rotation will cover more in avial tree, but for now, those who know about avial tree might know about this concept. So you have 18, 15, 16. So LR rotation. First of all, metric swap the bottom two nodes. So 18, 16. Now 15 is less than 16. So like then we have 16 as a root, 15 as a left child, and 18 as a right child. Now remember, when you rotate, the color of the bottom node will not change, whereas the node which becomes the parent will always be the black node. So till now we have seen that we made the tree. Now let's select our color. So 10, then 7. I've shown you the steps of rotation, but let's add an intermediate step for better understanding. So this will be a black, 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 red, and red. Now I told you, now let's rotate it. How will we rotate it? 10, black, 7. Let's not write the colors right now. Let's focus on drawing the tree first. So 15 is less than 16 and 18 is greater than 30, greater than 16. So now we were told to rotate and then recolor. So first of all, we'll see that we'll not change the color of the bottom node when we draw the intermediate step. So in this intermediate step, we have 15 as a bottommost node. So 15 will remain as red, but 18 was earlier black, now red. 16 becomes the root, so black, and 7 will be black. So now we have inserted 10, 18, 7, 15, 16. Now we have to insert 30. So now let's go on to the next slide. Now we have to insert 30. So 10, 7. In your exams, you'll have to show all the intermediate steps. If I'll miss some, that does not mean that you also have to skip them. So now we have inserted 30. 30 will be greater than 10, greater than 16, and greater than 18. So now let's tell the colors: black, 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 red, red. Now this will be red as it's the new leaf. So what we observe? Red, red. Red, red. Uncle is red. We remember this: grandfather, uncle, parent, child. Remember this? So by this we can see uncle is red. Recolor. So when you recolor, you'll get it as 10, 7, 16, 15, 18, 30. 30 will remain red, 10 will remain black, 7 will remain black. Now recoloring. 18 will become black, 15 will become black, and 16 will become red. So after this, we had to insert 25. Where will we insert 25? 25 is greater than 10, greater than 16, greater than 18, but not greater than 30. So 25 will be coming to the left of 30. Red color. So now again we have a red, red together. So now the uncle rule. Uncle, if not here, then it should be here, but it's not here. So go up, then go one more up. It's black. So we have to perform rotation. So now let's see on our next slide how we'll rotate it. So for rotation, we have 18, 30, then we have 25. So this is your right, left, RL rotation. In RL rotation, what we'll do is we'll first exchange the bottommost nodes. So 18, 25, 30 is greater than 25. And we know we'll not change the color of the bottommost node. Then 25 will become the topmost node with 18 and 30. So now let's implement it in the main tree only. So that will be easier to understand. So 10, 7, 16, 15, 25, 18, 30. So now coloring black, black, red, black. Now this will become black. 18. The bottommost node was, let's check. The bottommost node would be 30. So we'll not change the color of 30, but we'll change the color of 18. Now we have to insert 40. This is our last insertion. Red again. Red, red, uncle red. Red, red, uncle red. So recolor. So now when we recolor 10, 7, 16, 15, 25, 18, 30, 40. Now the colors, we'll just not change, write the colors of these notes. 25, 18, 30, rest we'll mention it as it is. So red, black, black, 18. Now we'll not write out 25, we'll check if it's changed, we'll change it. So 40 will be red. Leaf is always red. Now we move to 30. 30 will become black. Is 25 the root, the main root? No. So we'll change the color to red. Then after that, we'll check 18 is red, so now it will become black. So now you must be thinking it's balanced, but it's not when you see it clearly. Now, do you see a red together? Yes, we do. So what we'll do? Check the uncle. Uncle says black. Black means rotate and recolor. So let's go. So this will be basically our last step, I think. So for rotation, we'll take 10, 16, 25. Bottommost node, we'll rotate to 25. How? Right, right. Rotate it to left. The empty area, you'll rotate. Okay? So now let's draw the final tree. The final tree will be 16, 10, 7, 15. We'll have to adjust all the nodes that were earlier on the right side. But now if the root is 16, we'll have to see earlier 15 was on the right subtree. Now if 15 is less than 16, it should come on the left subtree and arrange it accordingly. Now suppose now we have 10 as the child of the root. So now 15 is greater than 10, so it should come on the right side. Similarly, after 16, we'll have 16, 25, then we'll have 18, then we'll have 30, and then we'll have 40. 40 is red, we know. 16 will be black. Now, this will be, I'll have to see the colors, but basically this will be black. We'll copy the colors, we'll see them. Then this will be black, this will be black, and this will be black, and this will be red. Now we know this cannot be red, so it will become black. This was red now. Then this one, 16. 16 was not the bottommost node, so red. So if we draw the final tree, so we'll draw it more clearly so that it's visible. So this will become red, this will become black. So no more inconsistencies. So we don't have any red combination. Now let's check the black depth. Now suppose if I go from here this side, if you go in the left subtree, we found one black. If we go this way, one black. If we go this way, one black. If we go this way, one black. By mistake, this one is black is here, so we'll erase that because then it may cause any confusion. So now see one black, one black, one black, one black. Assuming this as we don't, we can count it also, but then you'll have to count it every time. So I don't count this one. So one black, one black, one black, one black. So this will be our final tree. This is our final red, black tree. So this was your first example. So now in the next lecture, we'll solve one more example, which will be a little more difficult than this and which will allow more of thinking. And then after that, we'll start AVL. AVL, we have covered some part of rotation which we had to cover in AVL. So in AVL tree, we'll be able to understand this concept better. So thank you. If you like the video, do like, share, and subscribe. Thank you.